Good afternoon. Thank you to ARC organizer for giving me the chance to share the installation of wireless gas detectors downstream of Petronas. This afternoon, my colleague, Mr. Ali, has presented upstream version of the wireless gas detectors in the track 3. So I'm representing downstream. We have installed about 12 numbers of wireless gas detectors. I will share a little bit. I'm Principal Engineer, Instrument and Control, Petronas. This is a Twin Tower. This is the office of Petronas, and we are proud sponsor of the Formula One. Last year, we are the champion in collaboration with Mercedes and also BlackBerry. I'm also using BlackBerry. And Petronas incorporated on 17 August 1974, and we are ranked among the Fortune Global 500 companies. And we are leading oil and gas multinational oil of choice. And we have actually 2 refineries. I'm from the East Coast refineries. Our job is to refine the crude oil, the sweet crude oil, to this product, LPG, petrol, diesel, reformat. Sorry. And we are also processing the condensate to produce the benzene and paraxylene. So it is basically an integrated refinery and petrochemical. Okay, today I would like to share the 3 topics, basically fire and gas mapping, which is, and then wireless gas detectors and the benefits and the lesson learned from the installation. Okay, fire and gas mapping. Petronas Refinery conducted its fire and gas mapping exercise in 2011. When I joined the company, I was from LNG, liquefied natural gas, in 2000 and 2010, and I transferred over to Refinery Terengganu. Then I started the fire and gas mapping because I see it very important to see the adequacy of the installation of the existing gas detectors in the plant. During project, gas detectors has been installed based on the project rule of thumb. But over time, you must revisit back the adequacy of the installation based on the scientific model, based on the quantitative risk assessment, and that will give you more accurate installation of the gas detectors so that your plant can be operated safely and reliably. The fire gas mapping recommendation were to be implemented in phases according to the rollout plan. So because the project is quite massive, we staggered over 5 years. So we have started installation in 2012 in one of the areas, and in 2013, 14, and so on. In 2013, we are to install the gas detectors in the terminal areas. Terminal areas is where the tank farms, it's very big areas. And the challenges to install is basically, one of them is the remote location, such as tank farm, make it difficult for cable routing with barn walls and road crossing. If you look at the map here, this is a plot plan of the tank farm installation that we intend to install in the tank farm. And this is the tank farm areas, right? And this is the far building, which is where the control room is located. In order to lay cable from here all the way to the tank farm, it takes about 2 kilometers, the distance. So we have an options of installing wired gas detectors, or we have an option of installing wireless gas detectors. In year 2012, I met Penny, and we have some discussion over the possibility of using the ISA 100. And we make a research. And there is a company who is able to really have their gas detectors wireless using the ISA 100 and then connected to our control system. Okay. If looking back, the challenges that we want to do this project, as I mentioned, we have the options of wired or wireless. If we were to install wired, then the challenges is the scarcity of spare junction box at site, the high risk involved when laying new cables for detectors, especially excavation. Installation and commissioning of new detectors have to be done online while plant is running. And of course, the remote location where the crossing, the barn walls, everything will consume a lot of cost by the wired with the cable installation. Okay, this is the tank farm areas. Okay, this is, okay. With that 2 kilometers home run, and branch cables required, then using a wide solution, the large capex is required. So we need to really look at the budget that's allocated and the technology that you want to adopt. Okay, so the solution is basically wireless gas detectors. The success factors is proven in use. So we are looking around, where is this wireless gas detector has been installed? We don't want to be the first to install and then fail. We need to look around, and we know that it has been installed in some places. So that's where the proven in use category is very important. The product maturities compliant to ISA 100.11a wireless communication standard satisfy the EX requirement because we are going to install in the explosion-proof areas. Interoperability with existing wireless network and host DCS. In this case, our host DCS is Yokogawa, used for monitoring purposes only. Okay, wireless gas detectors, it cannot be used as the safeguarding because wireless is basically cannot for safeguarding. It can only be used for monitoring. Our existing system is also have some kind of detectors. They use the linear sheet detectors or the fusible tube. So the fusible tube is being wired, is being cabled around the mechanical pump. So if there is any pump failure, mechanical leakage, there is fire because of the gas leakage, that will burst the tube. And when the tube was burst, then the pressure drop, then detectors will detect and the operator will go and check. That is a conventional methods of fire detection. That is a reactive mode. So what we are looking for is a gas detector, which is a proactive. Before the fire can occur, we detect first the gas. This is what we are doing. Wireless gas detectors. Okay. As I mentioned, we do a market research on the existing possibility of wireless gas detectors in the market. Remember, this is 2012. We have 7 units of gas detectors tested in Yokogawa office in the plant Norway. There's another second test in the Norway area also with Yokogawa system. And the third one in Japan. And the test number 4 is done in Malaysia, Yokogawa, Malaysia, witnessed by Petronas, by my team. So we have this test criteria. For example, the speed of response, accuracy, the low battery alarm, the communication errors, the battery lifetimes, whenever if there is a heavy rain, what happens? There's a lot of criteria, acceptance criteria that we rigorously go through to make sure that the installation are successful and they have passed all these tests. Upon passing all these tests, then we proceed. And these are the team that basically do the test in Malaysia, in Yokogawa office in Malaysia. And these are the schematics. We have pump area A, pump area B, and pump area C. So we installed the gas detectors near the mechanical pump, where the potential leakage is coming from the leakage, from the mechanical seal, And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there are actually total of 12 gas detectors, wireless. And these are the transmitters and these are the receivers. And this is actually connected via Modbus to DCS, Yokogawa DCS. The challenges that we encounter. The transmitters could not start up and gave a red indication light during commissioning. This is actually the gas detector. This is transmitters. Cause was the fiber optics between the transmitters and the receivers were damaged, and no connection could be established to the receivers at the control room. So impact was poor quality of the fiber optics can significantly affect transmission of the signal. So during that commissioning, we have encountered poor quality of fiber optics because we use the fiber optics to transmit the data. The other problem that we encountered during that time was no connection between the gas detector pump house and the transmitter receiver at the substation. So because of the no line of sight. So the way forward was omnidirectional signal propagation needs attention when installation involves enclosed area. So we need to really make sure the line of sight. So the way we solve this problem is install a repeater. We install a repeater to establish a clear line of sight between the two locations. So we need a repeater to boost the signal. The third challenge that I did not mention here is the battery life. The vendor realized that during the installation, there are also a possibility of lost communication because of the problem, for example, the fiber optics issues, or maybe the line is not ready. So what happened then, when you power up the gas detectors, it will keep on trying to look for the receivers. And this keep on looking for the receivers, causing the battery to drain very, very fast. So instead of 2 years guaranteed by the vendors for the battery, it went drained after 1 month. So what they did was they improved their system as such that whenever they try, look for the third time, then they will stop. They will not looking for the receivers. They will stop. Then they will try another random time in the futures. So by this method, it has improved the battery life of the gas detectors. Okay, this is the actual site installation. This is the antenna. These are the antenna. These are the antenna. Okay. And these are the gas detectors. And you can see the mechanical pump, the mechanical seal areas, and these are located here. And these are the gas detectors. We have about 12 numbers of wireless gas detectors. Just to briefly explain, the gas detector is using infrared technologies. To preserve the battery, what they did was they have a built-in acoustic sensors. These acoustic sensors will be on the continuous monitoring. Whenever there is a leakage of gas, it will hear the sound. And by the sound, it will trigger or wake up the infrared sensors. So the infrared will start doing the sensing. That's how the technology of these wireless gas detectors. And the benefits, lesson learned, of course, quite obvious. Reduction in overall project risk because we don't have to excavation and all this stuff. Working at height. Installation can be done quickly, safely, and seamlessly while plant is online because nothing, no cable excavation. Simplifies engineering and drawing updates. Reduction in overall project costs. And the lesson learned is good stakeholder management, client, principal, local business partner, and vendors were involved right from the beginning. Good communication plan, support from all parties to ensure that the system was tested to the client's requirement, and need to pay attention to future upgrades of hardware that may affect the network. So if there is an increase in numbers of gas detectors, we need to make sure it will not affect the network. And these are the graphics of the DCS. The DCS is using Yokogawa system. You can see these are the diagnostics. We can see if normal is green, the alarm is this color, cyan color. Fault is yellow, and the maintenance is in this purple. You can see one of the gas detector under maintenance require maybe battery replacement. I took the shot before I left my plant. And you can see one of the detector is in the fault condition, so I've already instructed my guy to actually check it. This actually happened after a big heavy heavy rain. I was thinking whether is that raining causing this issue. I checked with Penny whether IC 100 cannot penetrate to the heavy storm, but he said no. Okay, I'll check later on what's causing this fault. We have actually another 10 detectors, which is okay, which is here, this. The rest are all the gas detectors, which is okay. Okay, with that, I thank you very much.